Good morning, hope you're doing well. Today we will start with Chapter 13, Electrical Safety. Electricity is very important nowadays. However, it can pose a significant danger when mishandled. At the end of this lesson, you'll be able to identify the effect of high current on the human body, specify how to protect individuals from electrocution, describe how electric installations are protected, and finally, explain the effects of a short circuit. The human body is a good conductor of electricity. A voltage higher than 24 volt in a wet environment or higher than 50 volt in a dry environment can cause a current higher than 30 milliampere in the human body, thus leading to electrocution, which is a severe injury caused by an electric shock. The effect of electricity on humans is related to the value of the electric current. A current equal to 1 milliampere results in a slight feeling of pain. At 2 milliampere, a person feels a mild shock. When the current reaches 10 milliampere, a person cannot let go of the wire or appliance. You should never touch an electrocuted person because you can be electrocuted as well. A current equal to 20 milliampere can lead to muscle contraction. At 30 milliampere, a person suffocates and has respiratory problems. The human heart stops at 100 milliampere and the breathing stops at 300 milliampere. A current equal to 900 milliampere causes severe burns. The voltage of the electricity at homes is equal to 220 volts. Thus, it is extremely dangerous. An electric appliance is connected to the electric socket by two wires surrounded by insulating layers of plastic with different colors. The black or blue color represents the neutral wire, and the red color represents the live wire. Let's suppose we are trying to move the washing machine and the insulator surrounding the wires got damaged. These wires are now in direct contact with the metal of the appliance, which is a conductor. If you touch the washing machine now, you will be electrocuted. To avoid electrocution, we connect a third wire which has a green color and is called grounding. Grounding prevents electrocution by sending the electric current down to the earth, thus preventing accidents. Another method that ensures electric safety is a circuit breaker. Ask your parents to show you the circuit breaker in your house. A circuit breaker protects automatically electrical appliances and prevents electrocution. How does a circuit breaker function? Let's suppose that a washing machine, an iron, and a lamp function at the same time. By applying the law of addition, we can calculate the current across the three appliances, which is equal to 23 ampere. This current is greater than the current that the circuit breaker can hold, which is 20 ampere. Then it will be overloaded and it turns off, leading to an open circuit and interrupting the current flow. Keep in mind that there is a variety of circuit breakers with different values. Pay attention that we should check for the cause of the overload or leakage before turning the circuit breaker back on. Many devices, such as washing machines and televisions, are protected by fuses. A fuse is mostly a glass tube having at its ends two metal caps. Inside the tube, there is a thin metal wire. Each fuse has a rating that indicates the maximum current that it can hold. A fuse is connected to a circuit. When the current is higher than its rating, the metal wire melts, leading to an open circuit. Then the current cannot flow anymore, thus protecting the components of the circuit. Let's consider the following electric circuit. We connect a connecting wire to the terminals of the dry cell as shown in the figure. This connection is called a short circuit. The short circuit results in an excessive current flow and causes overheating of the dry cell. As a result, the dry cell is exhausted and the lamps turn off. The dry cell may become damaged. Now we will connect the short circuit to one of the lamps. We notice that this lamp doesn't glow anymore. because now the current flows through the connecting wire. The brightness of the second lamp increases since the current flowing through it becomes larger. A fuse and a circuit breaker are used to protect from a short circuit. As we said previously, even though electricity is very important, it can be dangerous if not used with precaution. It's very dangerous to use electrical appliances when the body is wet or around water. Damaged cords can cause electrocution. That's why you shouldn't pull on the wire when unplugging a device. Avoid connecting too many devices on the same socket. It can heat up and cause a fire. Use plug covers, especially around kids, to avoid pushing metal objects into a wall socket. Study the notes very well, then please open your books to page 110 and solve all the exercises. Stay safe.